This video will cover the essential aspects of blood glucose control for your exam. We will explore the roles of the pancreas, insulin, glucagon, negative feedback, and diabetes, all key areas in GCSE Biology homeostasis. Homeostasis is maintaining a stable internal environment despite external changes, with blood glucose regulation being a primary example. Every cell needs glucose for respiration, so levels must be kept within a narrow, safe range at all times. The pancreas is the body's blood glucose monitor, acting as both a sensor and a control center. It constantly monitors glucose levels in the blood and triggers the appropriate hormonal response. Two key hormones regulate blood glucose. Insulin is released when glucose is too high, signaling cells to take up glucose and convert excess into glycogen for storage. Glucagon is released when glucose is too low, signaling the liver to break down glycogen into glucose. When blood glucose is too high, the pancreas releases insulin. Insulin signals body cells to absorb glucose, and excess glucose is converted to glycogen and stored in the liver and muscles, bringing blood glucose back down. Glycogen is a large, branched molecule made by linking many glucose units together. It's stored in the liver and skeletal muscles, acting as a glucose battery to be released when needed. The insulin action loop starts with detection by beta cells in the pancreas, followed by secretion into the bloodstream. Insulin binds to receptors, leading to glucose uptake by cells, and storage as glycogen, lowering blood glucose. When blood glucose falls too low, the pancreas releases glucagon from its alpha cells. Glucagon travels to the liver, stimulating glycogenolysis, the breakdown of stored glycogen into glucose. This glucose is released into the bloodstream, raising levels back to normal. The glucagon action process begins when blood glucose falls. Glucagon is released and travels to the liver. The liver then breaks down stored glycogen into glucose, which is released into the bloodstream, restoring normal levels. Blood glucose regulation is a classic example of negative feedback. When levels deviate, the body triggers a response that reverses the change, keeping internal conditions stable at the ideal set point. The negative feedback loop continuously makes tiny adjustments. When blood glucose rises, insulin is released, leading to glucose uptake and storage. When it falls, glucagon is released, causing glycogen breakdown and glucose release, thus maintaining a safe range. Remember this critical fact: insulin lowers blood glucose, and glucagon raises it. This is the most frequently tested fact in this topic. Don't confuse these opposite functions. Here is a summary comparing the features of insulin and glucagon. Insulin lowers blood glucose, promotes glycogen storage, and acts on liver, muscle, and fat cells. Glucagon raises blood glucose, promotes glycogen breakdown, and acts on liver cells. Diabetes is a medical condition where blood glucose is not properly regulated, leading to dangerously high or low levels. Over time, poorly managed diabetes can damage blood vessels, nerves, kidneys, and eyes. There are two main types. Type 1 diabetes is an autoimmune condition destroying the pancreas's beta cells, resulting in little or no insulin production. Type 2 diabetes involves insulin resistance or insufficient insulin production, often linked to lifestyle factors, and is sometimes preventable. In type 1 diabetes, the immune system destroys insulin-producing beta cells. Without insulin, glucose cannot enter cells efficiently, causing blood glucose to rise to dangerous levels and leading to serious complications. Treating type 1 diabetes relies on insulin therapy. Patients must inject insulin or use an insulin pump to supply it artificially. They must also monitor glucose levels, balance carbohydrate intake, and adjust insulin doses carefully. Insulin can be delivered via injections using a pen or syringe, typically before meals. Alternatively, an insulin pump delivers a continuous, controlled dose throughout the day and night. Patients also monitor glucose via finger prick tests or continuous monitors. In type 2 diabetes, cells become resistant to insulin, so they do not respond to it properly. Blood glucose remains high, and cells are starved of energy. This condition damages tissues and organs over time. Risk factors for type 2 diabetes include a poor diet high in refined sugars, physical inactivity leading to weight gain, and obesity, particularly abdominal fat. Genetics also play a role, increasing risk if a close family member has the condition. Type 2 diabetes is often managed or even reversed through lifestyle changes, including a healthy diet and regular physical exercise, which improves insulin sensitivity and maintains weight. Medication or insulin may be needed in advanced cases. 3 key lifestyle changes help manage type 2 diabetes: eating a balanced diet, exercising regularly to improve insulin sensitivity, and maintaining a healthy weight. Losing just 5 to 10% of body weight can greatly improve control. Here is a comparison of type 1 and type 2 diabetes. Type 1 is autoimmune, producing little or no insulin, and is treated with insulin. Type 2 is caused by insulin resistance, produces less effective insulin and is treated with diet, exercise, and medication. Hyperglycemia is high blood glucose, causing thirst and fatigue and leading to long-term damage. Hypoglycemia is low blood glucose, causing shakiness and confusion, and is a medical emergency if severe. The normal range is around 4 to 7 mmol per liter. The liver is central to regulation, acting as the primary glucose buffer. It performs glycogenesis, converting glucose to glycogen for storage, and glycogenolysis, breaking glycogen back into glucose for release, balancing blood sugar levels. Negative feedback works because the body's response always opposes the change that triggered it. If glucose rises, the system lowers it. If it falls, the system raises it. This mechanism is automatic, rapid, and precise. This diagram summarizes the whole process, showing how both high and low blood glucose pathways lead back to stable blood glucose. This represents the essence of negative feedback in maintaining homeostasis. Key terms include homeostasis, maintaining a stable internal state; insulin, the hormone that lowers blood glucose; glucagon, the hormone that raises it; and glycogen, the storage form of glucose. These are all controlled by negative feedback. Avoid confusing insulin and glucagon's actions, stating that the liver instead of storing it as glycogen, mixing up type 2 diabetes, and forgetting that glycogen is stored in muscles as well as the liver. Finally, here are some practice questions covering key concepts like the role of the pancreas, how the body responds to high blood glucose, the differences between type 1 and type 2 diabetes, and the overall negative feedback regulation system. Let's review the model answers. The pancreas produces insulin and glucagon. High glucose leads to insulin release, promoting uptake and glycogen storage. Type 1 is treated with insulin injections, while type 2 is managed with lifestyle changes. For your exam, remember the golden rule: insulin lowers, glucagon raises. Use precise language like stimulates when describing insulin's action. Always mention the conversion of glucose to glycogen, and link the entire process to negative feedback. Quick recap. The pancreas monitors glucose. High glucose triggers insulin, storage, and falling levels. Low glucose triggers glucagon, breakdown of glycogen, and rising levels. This is all negative feedback. Remember the difference between type 1 and type 2 diabetes treatments. We have successfully covered blood glucose control. Next, we will explore another crucial homeostatic process: osmoregulation, focusing on how the kidneys and the hormone ADH maintain water balance in the body. You have completed the blood glucose topic. Remember the key roles of the pancreas, insulin, and glucagon, and the distinction between the types of diabetes. You are now prepared for related exam questions. Good luck!